Right, so next I'd like to show you the new plotting feature. So let's for instance say that we're interested in plotting delta f over f, comparing applying global signal regression versus not applying global signal regressions for various ROIs. So let's go over here, we click delta f over f and GSR, and now we're filtering and we're only looking at the files that had all of those manipulations versus everything plus GSR. So to do this, we'll need some coordinates, some ROIs. We'll get those from the Allen Mouse Brain Atlas, Connectivity Atlas. Open these and you can see here's a whole long list, an extensive list of coordinates. The ones that are likely off is probably because my location of Bregma is a bit wonky. I would like to note that when we have ROIs this much, the app does kind of slow down a bit. So I can actually show this. If I tried moving this, it is getting a bit laggy. Just so you know. So that's completely normal, and I am not looking to fix that anytime soon because I don't think anyone's ever going to use this many ROIs at once. So just so you know, if you go to the help feature here and you go about Miso Brain Explorer, click the link here. This takes you to a help page where it gives you all kinds of information. Links to this video would also eventually be up here. And also here is all of the ROIs that I have just loaded into the application. See, every single ROI has a length of 1. You can change that. It doesn't have to be. If this was a 3, then this ROI would be a 3 by 3 square instead of a 1 by 1 for 1 pixel. And yeah, the coordinates are in microns for no other reason than because our units per pixel over here is on microns. But whatever units you use here is the units that your x and y coordinates should be. And of course, these are all relative to wherever you placed your x and y. So let us get to plotting. Oh, and also just the next thing is you can move this around if you wanted to adjust where all your ROIs are. So I can maybe actually get most of these ROIs into the mask, just like that. As you can see, that was very easy. Note that you do not want to change the units per pixel and then process things after that. So if we, for instance, say, let's see, make this more. So 1 pixel is a larger distance now, but the problem is that each one of these ROIs stays the same size, and since when we imported them they were 1 pixel large, each of them now is less than a single pixel, which means when you plot anything, you'll get nothing because you cannot have a fraction of a pixel represented. So whenever you have this case whenever you change your units per pixel, click the Update Table button, right? And you'll notice that everything now has been readjusted. So each one of these is now the size of your new 52 units of pixels. Of course, 52 is not correct because of the, oops, update again, because of the, what do you call it, resolution, widescreening, or whatever you call it, of our camera. 41 microns per pixel is correct for the camera that we used. Right, so anyway, moving on to plot ROI activity. Over here you can see the various options. And again, this doesn't reset like it used to anymore. So if I went back to import CSV, you can see these are still selected. If I went back to plot ROI, yay, very convenient. It maintains whatever you filtered it to be per plugin. So let's actually finally get to some plotting and see this in action. We can select all of the things we're interested in plotting. So let's pick everything that is that's GSR, and let's pick some interesting ROIs. Many of these I have no idea what they are, but I mean I know what hind limb is. Motor 1, motor 2. I want to get at least 5. Okay, fine. Let retrosplenial. Okay, 1, 2, 3, 4. One more. Okay, fine. Let's take the right barrel cortex. Okay, that's fine. So After we've made our selection, we can click plot activity at the bottom here, and it will process itself and find all of the activity across image stacks for each of those ROIs, and do that for each and every single one of these videos. And here you can see beautiful and lovely tables showing everything. So let's break down what we're actually looking for. Again, as you can see at the very top, your window has an ID, a unique ID that was made, and you can create, still use the help button for contextual tips. There's no help button up here. There doesn't seem to be a way to put it here, but if you go back here, click the help, what's this, and eventually I will implement it, but if you were then to click on this window here, it would like give you tips on how to do things. But I will just show you now. So there are dockable windows here. Every single one of these is a single ROI, and you can see all of the image stacks are being plotted for each one. So these are the three image stacks we selected, and then this is the barrel cortex for that. If we click on this tab over here, you can see M1. All of these docks are also movable. So for instance, if you wanted to, you could move this here, and you can see it like that. You can also stack them all on top of each other if you wanted to see everything in one full-blown thing, and then you can manipulate that like that. There's a couple of other manipulations you can do. If we go to a transform over here, one that I particularly like is the average one. So there you can see that green line in the middle is the average activity of all three of these. So we have 3 image stacks. We're looking at the 1 ROI for each one of these, right? And the average allows us to see the average activity for all 3 of those. And then of course the most important part is for any one of these at any point in time, you can select this, go to export, and that will go to CSV data, and this will then export your data here into some CSV where you can do something else with it later, right? Another thing, I'm not sure how useful it is, but it's nice to have, I suppose, is you can apply, where is it? Right, power spectrum. And I believe Matthew Varney sometimes uses this. By the way, something you can do as well. Right, but my favorite part is that you can in fact save this table. So let's go back to the app. We click the Save Plot Windows button. This will look at how many plot windows are open, and we'll save each one in turn. Okay, so we click OK. You can see here this is the ID of the window, and we're now going to pick a name for it. So we know this one is GSR, so I'll just name it GSR. Save it there, and this has now been saved. So if we were to close this, as a matter of fact, let's go a bit further, and now let's plot everything for without the GSR. Right, so here's the output of delta F over F activity without global signal regression applied. Of course, we have a different ID because each one is unique, and again, we can save this plot window as well. So there are 2 available. So we have to make sure what the ID is. This is okay. So D8. This should be GSR. Yeah, that's fine. Already have that one. C5. This is just delta F over F naught. I'm gonna make that underscore. Okay. So after we've done that, we can quit these files. You can even quit the app just to show you. So now you've come back to the app a couple of days later, and now you want to look at your files again. You just click Load Project Windows, and then you can see everything has been opened up. And now you can also see that since you've renamed it, you have delta F over F for this one and GSR for this one. Note that you can also save both of these at the same time. Look, there are 2 GSRs. Oh well, that's interesting. I guess I'll fix that later. So yeah, we could have also saved both of them at the same time. I did them one at a time because I think these are pretty hard to differentiate based on the ID alone. Anyway, one more. Right, so I'll quickly show you what the seed pixel correlation maps now do. Over here I've selected all of the previous image stacks we use and just the normal standard seeds, so Baroque Cortex, Hind Limb, M1 and V1. So generate. Actually here I'll show you some of the processing just so you know what it looks like. This is totally normal. You cannot interact with the application while this is going. Also, the abort button for many of these dialogues don't work yet. I am working on getting to that eventually. So yeah, you cannot cancel this while it's processing. Yet. Okay, so this is actually something I'm still working on. So in hindsight, I obviously did this the wrong way around. Each doc right now is a single ROI, and then the tabs are you going across different image stacks. You'll see that there's only 3 because the other one was just too ridiculous, so I redid it. Yeah, what I should have is the ROIs at the top here as tabs, and each one of these as a single image stack. But yeah, and each one of these has a range that you can see here. It doesn't do anything yet, but what this will eventually allow a user to do is to specify the range that's visible. So you can imagine the upper range being 0.5, and then only correlation values below 0.5 will be viewed. And as you can see in the top left, the correlation value as you hover over this is also displayed. And of course, this will be savable like the plots that you've seen already, and the color map that you save won't be saved with it, so you can change color maps easily and on the fly. Like the data, the array that makes up the color map you save, not the actual color data itself. And you can also export the image directly if you want a bitmap or a JPEG of a particular ROI, say a particular seed pixel correlation map after you've messed around with these values up here. Yes, and as I said, I'm still trying to figure out what the best ways of doing this, so please do give me tips. So one last thing I quickly like to touch on is why can some plugins not be automated? Some plugins are just not part of this automation feature. So an example of that would be channel division. The reason for that is because it's not clear how it would take input that is of an arbitrary size. So channel division, the idea is that you have a single multi-channel image stack and you're dividing one channel versus the other frame by frame to get a ratio. But the input to this seems to always be 2 image stacks. So if you have a pipeline and there's 50 image stacks that you're processing, after you get the output of, say, 50 image stacks from delta f over f, and you want to feed that to channel division, it's not clear how channel division is going to accept that input. So as a result of that, channel division is a plugin that you can only work with manually and will remain so for the foreseeable future. However, of course, you could extend